Okay, this is Mr. Lima with a workshop for rational number arithmetic. This is not a replacement for doing the hard work doing a unit in rational numbers. If this is the only video you watch, I can't promise you that it's going to be enough for you to pass the content assessment. It's going to take a while to review all the skills in this unit, but this is not a comprehensive video that talks about all of those skills and details. It's not a replacement for using something like Khan Academy or MobiMax that do a much better job than my tutorials, or watching my tutorials, or doing well in class, or reviewing with the unit notes, doing the homework, doing the heavy lifting, the practice that it takes to actually learn these skills. But if you're really close, or you need a review, or you just want to try something, I hope that you find this helpful. So let's start here with adding. The rules for adding, remember, are supposed to be that if the signs are different, or the two numbers that you're trying to put together, then you find the difference between them, between the values, and keep the sign of the number with the biggest value. Right? Now, as an example of this, right here in the bottom where we have 14 and -5. So they're different signs. So I'm supposed to find the difference between those values, and that's 9. So that's my answer. And then I keep the sign of the biggest number, which is 14, so the answer is going to be 9, right? In the other videos, I explained the logic of this a little bit better about why this makes sense. Now let's try this one here, which is also two different numbers, except this time we have -14 and +5. -14 and +5, it's also going to be two different signs, so you're going to find a difference and answer it 9. But because 14 is the bigger value, you actually have to keep the sign of the biggest, and then the answer is -9. All right. Now, if the signs are the same, you are supposed to put numbers together, or it's another word for saying add them, and then keep the sign of the number with the biggest value. So it's the same thing always. Now, of course, if the signs are the same, keeping the sign of the number of the biggest value is just going to be whatever sign the problem has, because they both have the same sign. Here, for example, -14 and -5. So obviously, if I'm going to keep the sign of the biggest, and they're both negative, the answer is going to be negative. And then I just put them together. 14 and 5 make 15. Last but not least, we have these two. Same thing. Keep the sign, put them together, 19. Now, if you are adding opposite or numbers that have the same number but different signs, the answer is 0, okay, because they cancel each other out. So here's an example of that. 4 plus -4 should be 0, okay? Now, it is also important to think of this in terms of how you move in the number line, or good guys versus bad guys, and actually understand why this makes sense. It will help you better than memorizing the rules. But for the purpose of the workshop, that's what I'm doing. Now, remember also that the rules for adding are not the same as the rules for multiplying and dividing. You notice, for example, we're putting two negative numbers together. We make an even bigger negative number. So you're going to notice that when we multiply and divide, that's not true. Two negatives cancel out. But you don't confuse one with the other. These are different rules. So here we have a little bit more practice with these skills. And what I would suggest you do is that you pause the video and actually try these before I do it. Notice that I'm doing several examples where the signs are the same and they're both negative. Signs are the same and they're both positive, and so forth. All right. And let's see what you get. It's always the same numbers, but the signs are changing. And let's see what you get with each one of them. Okay, so when the signs are the same, we're supposed to put them together. So both of these first here, because the signs are the same, I know that I have to put these numbers together. And 18 together with 7 makes 25. So I know that both of these are going to be 25 for my answer. Now, this one has a negative sign, so the answer is -25. And that's one's positive sign, so the answer is +25. So I'm just using the rules to my advantage. Now, when they're opposite signs, I'm supposed to find the difference. So I know that both of these will be 11, because that's the difference between 18 and 7. But in this one, 18, which is the biggest, is negative. And so the answer for this one would be -11. But the answer for this one, because the 18 is positive, would just be 11. Same principle in the next one here. when they are the same sign, we put them together. 8 and 3 together make 11. All right, so this will just be 11. But the one that has the positive sign will stay positive. The one that has the negative sign will be negative, because obviously if you're putting two negatives together, you make an even bigger negative number. Now, if you are having two different signs, like -8 and +3, then you're going to find a difference between them. So this is going to be 5. But the 8 is bigger and it's negative, so the answer is -5. And here, same thing. 8 and 3 different signs. The difference between them is 5. But the 8 is bigger and it's positive, so the answer is going to be +5. So that's some good practice with that. And now, let's try these quiz problems. So try, pause the video and try them on yourself, and then apply the rules and see what you get. Okay, so -9 and +6, there are different signs, so I find a difference. The difference between 9 and 6 is 3, and since 9 is a bigger number, I have to put a negative sign and be just like it. 6 plus 6 is just 12, and since there's no negative signs, obviously it makes sense that the two positives together make an even bigger positive. Here again, I have two of the same number, same sign, right? They're both negative. So of course I'm going to get a negative answer, because I'm going to get an even more negative if I putting two debts together. And since they have the same sign, I got to put the numbers together, and 4 and 7 together make -11. Different signs this time, and so I have to find a difference between them, and that's 12. And since 15 is a bigger value and it has a positive sign, the answer is +12. So that was some review on the rules of adding, and hopefully you found that helpful. Now let's move on to subtraction. Okay, so when you try to subtract, what you have to do is first copy the first number as it is, then change the operation to adding, but then change the sign of the number after that. And remember, by the way, never change the sign of the leading number. And last but not least, follow rules of adding. So let's try that with these examples here and see what we get. Okay, so in this first example, we'd have 14 minus 5. Copy down the first number, change the sign of the operation, and then change the sign of the number. It used to be 5. I changed it to -5, right? Now, remember, this is the same thing you get if you do slash the operation, change the sign of the number afterwards, right? And so now I follow the rules of adding. They are different signs, and so I'm going to find a difference between them, and that's 9, and keep the sign of the biggest, which is 14. All right. Next step, let's do 14. Change the sign of the operation to plus, then change the sign of the number that goes afterwards. It used to be -5, so now it's going to be +5. All right, so it looks like we're putting together two numbers which are positive. So that just means 19, following the laws of adding. Again, that will be the same thing as if you slashed here, and you notice how you basically just putting together two positive numbers. All right, on this one, don't change the sign of the leading number. -14, change the sign of the operation, and then change the sign of the number that goes after. It used to be 5, now it's -5. Looks like we're putting together two negative numbers. When you put together numbers that have the same sign, you just combine the numbers, add them, and keep the sign. So there it is, -19. And then finally, on the last one here, by the way, this will be the same thing once again as slashing here and then changing the next sign. So see, the double slash rule. Last but not least, you are doing copy the original first number, -14. Don't mess with the sign. Change the sign of the operation and change the sign of the next number. It used to be -5. Now it's +5. Looks like we're putting together two numbers with different signs. So I find a difference, which is 9. Keep the sign of the biggest. -14 is negative. So there it is, -9. So that's kind of how this works. But remember that you can also think about this in terms of moving backwards or forward in a number line, or think of it in terms of good versus bad guys, removing or gaining debt. And I talk about that in more detail in other videos. For the purpose of this workshop, I'm just using the rules to try to help you to pass the exam. But you're going to do better if you have an actual understanding of what's actually happening with the subtraction here. Okay, so let's do a few more practice problems. This time, pause before I reveal the answers on the video. Notice that we're using the same numbers every time, but changing their signs. Over here, we have the same sign, and they're both positive, but I'm subtracting those numbers. Same sign, but they're both negative. I'm subtracting those numbers, and so forth. And let's see what we get. Okay, so hopefully you pause the video. Over here, I have to slash this to change the operation, and then slash change the sign of the following number. So it looks like I'm putting together numbers that have different signs. So if they have different signs, I have to find the difference. And the difference between 13 and 6 is 7. And then keep the sign of the biggest, which is 13. So that's going to be positive 7 for my answer. On this one, I'm going to have to slash and slash again. Let's see what happens. If I slash here and then here, looks like once again, I'm putting together numbers that have different signs. And so once again, I'm going to find a difference, but keep the sign of the biggest, which is negative 13. So it's going to be negative 7 this time. All right. This time I'm trying to operate with negative 13 slash this and then 6, but I have to change its sign. So it looks like I'm putting together two numbers that have negative signs. And so I put them together. So the answer here is going to be 19 and keep the sign. So negative 19. All right. So let's do one more here. I'm going to change the sign of the operation, change the sign of the next number. So it looks like I'm putting together two positive numbers when I get to the rules of addition. And so I'm going to just combine the numbers and keep the sign. And that's my answer. Similar process to these over here. All right. So I'm going to slash them all first just to save time. Slash, slash, and slash. Change the sign of the next number. Change the sign of the next number. Change the sign of the next number. And change the sign of the next number. Notice I did not mess with the beginning. Now I just have to follow the rules of addition. 8 and negative 6 are different signs, so I find a difference. 2, keep the sign of the biggest, it's going to be positive. Over here we have, again, a positive and a negative, so the difference is what I'm looking for, but keeping the sign of the 8, which is negative, so negative 2. 2 sets of negative numbers being put together, so I'm going to get an even bigger negative number after putting them together, negative 14. And then 2 positive numbers put together, you just put together and keep the sign positive 14. So if that made sense to you, applying the rules, now we're going to actually practice this with trying to get these right. See if you can do so. All right, so I change the sign of the operation and change the sign of the number. So it looks what I need to do on this one is actually add to the negative 9, change the sign, and change the sign again, all right, to negative 6, used to be 6. So it looks like we're putting together two sets of negative numbers. Now, and for these ones, I'm actually going to try to intellectualize what's actually happening. So if I have negative 9, this is a debt, and then I take away positive 6, that means I lost even more money. So it makes sense that you're putting that together to form negative 15, and that's your answer. All right, so on this one, we do 6. Change the sign of the number that comes after. So I used to have $6, but then I took away $6. So what do I end up with? Nothing. The difference between them is what I'm looking for because they're different signs. And of course, since they're the same number, there's no difference between them. I'm adding opposites, and so it's 0. All right, so now I'm going to do change here and change here. So it looks like I'm putting together two numbers that have opposite signs, and so I'm going to find a difference. The difference between 4 and 7 is 3, and 7 is the bigger number, so I'm going to go with its sign. So it should be positive 3. Does that make sense? Well, let's see. If I had a debt of 4, and then I took away a debt of 7, that's like making money. So yes, of course, it's going to help out, and I'm going to end up with more money than I used to have before. So in this case, again, negative 4, change the sign of the operation, change the sign of the number, you end up with 3 because they have different signs, and you find a difference just like I said. Next, if I had 15, but I took away a debt of 3, oh, that's even better. It's like gaining money. So not only did I have the 15, I also got rid of a debt. So it does make sense that you're just putting those numbers together. So this will be, again, 15. Change the sign of the operation, change the sign of the number that goes after, and then that's the same thing as 18 because you're just putting together two positive numbers. So there's a way to contextualize this, right? To think about what's actually happening, to make sense of why you're doing it. Let's look at it again, but look at it from the sense of like moving in a number line, right? So if you move to the left 9, and then you do the opposite of moving to the right 6, that's the same thing as moving to the left again. That's why you end up with a bigger number. On this one, I am moving to the right by 6, but then I do the opposite of moving to the right by 6, which is moving to the left 6, and therefore you end up where you started at 0. If I move 4 to the left, but then I do the opposite of moving to the left 7, that's like moving to the left and then moving to the right. And so, of course, since I moved more to the right than to the left, then I'm going to end up with 3. Moving to the right 15, and then doing the opposite of moving to the left 3. That's the same thing as moving to the right 3. And of course, with the 15, I end up even more to the right. So whether you think of it in terms of something like money or moving around in a number line or just follow the rules that I showed you, you should be able to understand why it needs to be that way. And this takes practice to do well and to not make mistakes. But hopefully this video showed you how to operate with subtractions a little bit better. Now, let's move on to dividing and multiplying. Now, remember, we're just focusing pretty much on the rules here, the rules for multiplying and dividing. The first thing to remember is that you're going to operate normally as if with multiplication tables. Okay, so it's still normal division and multiplication. But if there are only positives, then the answer is positive. Now, if there is an odd number of negatives, the answer is negative. If there is an even number of negatives, the answer is positive. Right? So if you think of it that way, it'll be fairly straightforward to try to figure it out. And apparently I cannot spell the word positive. So these are the rules that you have to remember. That means, by the way, that if you multiply by -1, since there's only one negative, that you end up changing the sign of the number that you multiply. One more thing to remember is that if you multiply inverses, you also always get 1. All right, so these are some basic rules of multiplying and dividing that you can use. So this is just practicing the signs, right? So let's do this. I have 3 sets of negatives here, right? So first I operate the numbers, and all of these are just ones, so all the answers are 1. So really what we have to ask ourselves is the sign going to be negative or not? Now you see, there's 3 sets of negatives. That's an odd number of negatives. 2 of them can cancel each other out, but you're going to have 1 left. And so the answer is going to be negative. Here we have 4 sets of negatives. So you have 2 pairs that can cancel each other out. It's an even number of negatives. So the answer is going to be positive. Again, an even number of negatives gives you a positive answer. An odd number of negatives gives you a negative answer. And a positive number of negatives, right, even number of negatives, gives you a positive answer. So that's kind of how that works. And so let's practice this with some actual problems. Try these, pause the video, and then resume when you're ready. Okay, so -9 times 6. 9 times 6 is 54, but there's only one negative, so that's -54. 6 times 6, there's no negatives involved, so that's normal. You just get 36. 2 sets of negatives involved, so the answer is going to be positive. And 4 times 7 is 28. 1 negative involved, so that's an odd number of negatives, so the answer is negative. Nothing to cancel it out, so the answer is -24. Now let's do some division. The same rules apply to when you're dividing. Okay, so you just divide the numbers and then think about the sign. Now remember, these are different from the rules of adding. If you were adding these 2 numbers, you would get an even bigger negative number, but you're not. So don't confuse adding and subtracting rules with the rules of dividing and multiplying, the sign rules. So 9 divided by 3 is just 3, but there's only one negative. So the answer is going to be negative. 16 divided by 4 is 4. Since there's no negatives involved, the answer is definitely positive. Negative 4 divided by negative 2. 4 divided by 2 is just 2. And since there is only 2 negatives, they can cancel each other out. They pair up an even number of negatives. And so the answer is actually positive. 8 divided by negative 4 is 2. And then the sign, there's only one negative, so the answer is going to be negative. All right, let's do some more practice over here. All of these, by the way, have the same answer. All of them come out to 6. It's just really about what is the sign of the answer. Okay, so there's only one negative, so the answer is going to be negative 6. And here there's 2 negatives, so they can cancel each other out. The answer is positive 6. Here we have 3 sets of negatives, so they do not cancel each other out. So the answer is negative 6. Here we have 2 sets of negatives. They do cancel each other out. The answer is 6. Here we have 2 sets of negatives. They do not cancel each other out. The answer is 6. And here we have 4 sets of negatives. They do cancel each other out, and so the answer is 6. So remember, only when you have an odd number of negatives is the answer going to be negative. Now, there is a part of the content assessment that plays onto this by showing you that there's different ways to write expressions. Notice all of these give you 6, all of these, plus the one in number 2 also, right? So, but they can be written in different ways. As long as you have the same numerical answer, right, when you follow order of operations, and the same number of negatives, the expression is equivalent. Do be careful, though, with order of operations. Remember that you can't invert the expression if you have a division in there, because the order matters, right? So 50 divided by 2 is not the same thing as 2 divided by 50. So they're not going to be equivalent even if they have the same number of negatives. So on that objective 3, a lot of it is just a play off with this sign rules. You can write the expressions in a lot of different ways and get the same answer, so long as the order operation ends up giving the same numerical answer and you have the same total number of negative signs. So that's what you're looking for on those questions. Look for the same total number of negative signs in an operation that gives you the same numerical answer. So actually calculate with order of operations and make sure the number of negative signs is identical, and you're going to be okay. All right. So that is the basics of this content assessment, but there are a few other extra skills that might be important. And so I'm going to continue the video to talk about how to do adding and subtracting with decimals and with fractions, which will show up on the exam as well. The rules are the same, but you need to know this if you're trying to do well. So we'll review that on the next, from now on. So the next stage then, let's talk about adding and subtracting decimals. So you do this exactly like you did with adding earlier, except that you must, before you decide what you're going to do, you have to think about the rules of the signs. Then you line up the corresponding decimals and decide your final answer. Now, notice all of these are 5.6 and 3.2. So what I'm going to do here to save us time is add them first, or put them together first, is what I call it. And remember, to do that, you have to line up the decimals. So the tenths have to be together. Pad the rest with zeros, right? The 3.2 was missing a 0. And then vertically add them together. So 0.2 is 2. 6 plus 2 is 8. And then 5 plus 3 is also 8. So when we put them together, we get 8.82. How about if we were trying to find the difference between them? Put the bigger one on top. Line up the decimals again, pad anything that's not completed, and then find a difference. 0 to 2 is 2. The difference between 2 and 6 is 4, and the difference between 5 and 3 is 2. The answer has the same decimal lined up. So whenever we put them together, all right, this is together, this is what we're going to get as our answer. Whenever we find the difference, this is where we're going to put them together. But first, if we were doing this on a normal problem, I would have to first think about what is it that I need to do. So for example, here, when I have 2 sets of numbers with the same sign, what am I supposed to do according to the rules of adding? I got to put them together, right? So it's going to be 8.82. And the sign is going to be positive because I keep the sign. Now, in the next example, we have two sets of numbers, again, with the same sign. So according to the rules of adding, I have to once again put these together. So it's going to be 8.82, but it's going to be negative because I'm supposed to keep the sign. Next one, I have two different signs. So according to the rules of adding, I need to find the difference between them. And that's 2.42. I just did that. And I have to keep the sign of the biggest. So negative. And on this last one, I have two numbers with different signs once again. And so I once again find a difference, 2.42, and keep the sign of the biggest, which is 5.6, and so it's positive. You see, that's kind of how it works. Now, what if I was doing subtraction? I have to do the same kind of thing. I have to first operate the rules of signs. So I change the sign of the operation, change the sign of the number. So it looks like this is putting together a positive and a negative. So I need to find the difference and keep the sign of the biggest. The biggest is 5.62. So it's kind of like doing this. So my answer is going to be 2.42. Right? So a part of this is knowing how to actually subtract and add the decimals. But really, what's being tested on the test is that you know how to follow the rules. All right, let's try this one. We actually slash here and slash here. Looks like I'm putting together a negative and a positive. So once again, I find a difference. But the biggest is negative this time. So it's going to be negative 2.42 this time. I have to find a difference. All right, let's try the next one. I change the sign of the operation, change the sign of the next number. Looks like I'm putting together two sets of negatives. That's kind of like this one. You have to put them together and keep the sign. So negative 8.82 because we put them together. All right, let's do one more over here. And it looks like once we change the sign of the operation, change the sign of the next number, we're just putting together two sets of positive numbers. And so 8.82 is your answer. Now, let's try to find these principles when we're not looking at all the variations, right? Because that's what this was. All the different variations using the same numbers of adding and subtracting. Let's apply that now to new problems, one at a time, and actually follow the steps. I just wanted to show you all the variations that you could get, but now let's actually do following the steps. So first, I have to figure out the correct operation that I need to do. Am I putting it together or am I finding a difference? Well, it looks like I'm adding two numbers that are positive. So clearly I have to put them together so that I know that I have to add those numbers. So I line them up by decimals, 3.18, and then add it together. 8 plus 2 is 10. 1 carries over. Remember, with adding, if it goes above 10, it carries over. 1 plus 6 plus 1 is 8. And then 5 plus 3 is also 8. So this one is 8.80. And the answer is going to be positive since I'm putting together two positives. So 8.80 is a good answer for that one. Let's try the next one. Now I'm adding a negative number to a positive number. According to the rules of adding, I need to find the difference between these numbers. So to find the difference, I ignore the original signs and just write the two values with the bigger one on top and subtract them. All right. And so 5 to get to 3, I can't do it. I have to borrow from this one. So change this to a 2. And now this can become 13. 5 to 13 is 8. 2 to 2 is 0. So my answer is 0.8 when I find the difference. So I want to answer 0.8 for this, 0.8. But I have to answer negative 0.8 because I have to keep the sign of the biggest. So notice that it kind of looks confusing because when you actually did a calculation, you put the negative sign next to the 2.5 instead of the next to the 3.3. But that's not what you're doing. You are still doing negative 3.3 plus 2.5. It's just that when you do that, by the rules of adding, you're going to find the difference between those numbers. And that's what I'm doing here. Just find the difference between the values. Then I go back to my problem and actually think about the sign of my answer following the rules of adding or subtracting. All right, so here we have a subtraction problem. So I have to first change the sign and then change the sign again. So it looks like what I'm doing here is adding a positive number to a negative number. So I have to find the difference again. I have to do 3.8, bigger one on top, 1.2 on the bottom, and then find the difference between them. Difference between 2 and 8 is 6. Between 1 and 3 is 2. So my answer is 2.6. Now, the thing is that I have to think about my sign. And the biggest is 3.8. So 2.6 is indeed the answer. Now, let's do one more subtraction here. Change the sign of the operation. Change the sign of the next number. Then think about adding. I'm adding a positive number to a negative number, so I must find the difference. So once again, I put them vertically to find the difference between them. And that one's pretty easy to find a difference. It's just going to be 0.1. Now, yes, I want to answer 0.1, but I have to think about my sign. 1.3 is bigger and it's positive, so it's just going to be 0.1 positive. Last one here, change the sign of the operation, change the sign of the number that comes after. Looks like I am adding two sets of negatives. Because the signs are the same, the rules of adding say that I need to put them together. So that's what I'm going to do. I'm going to list the numbers and actually put them together. And this makes 3.3. Now, the sign of is negative because I am putting together two negative numbers. So my answer is negative 3.3. So whenever you are adding numbers involving decimals, you must first think about the operation that you're doing and see that if you have to put it together or find a difference, right? If they are the same sign once you're adding, you put it together. If they're different signs once you're adding, you find a difference. If you have a subtraction problem, you must first slash and slash to find out what is the adding problem you're actually doing. Once you finish the actual adding, think about the sign of the answer. Remember to keep the sign of the biggest. And that's how you add decimals. How about multiplying decimals? All right, so to multiply decimals, you must write them all down. It doesn't really matter if you actually line them up this time. I do like to put the number with the last number of digits on the bottom, but this time it doesn't matter because they both have the same number of digits. And I multiply pretending the decimals aren't there. 2 times 2 is 4. 2 times 5 is 10. And then I'm going to work for this 2, which is really a 20. So I'm going to put a 0 underneath the first column and start working underneath my 2. 2 times 2 again is 4. 2 times 5 again is 10. And then I have to add the numbers 4, 4, 1, and 1. And then I had one decimal here and one decimal here. So my answer has to have two decimals total. So 1, 2, the answer is here. So 11.44 is my answer. But then I have to do a final step where I think about the signs. These are both positive. So the answer is positive. If they were both negative, it would still have been positive, right? Because negative times negative is positive. Let's do one more example right here. 6.72 times, and remember, I like to write the number that has less decimals on the bottom to make my life a little easier. All right, so remember this is negative. It's going to matter later. 2 times 2 is 4. 2 times 7 is 14. 1 carries over. 2 times 6 is 12. Plus the 1 that carried over is 13. Now I have to work underneath the 3, so I put a 0 and start working under the 3. 3 times 2 is 6. 3 times 7 is 21. 2 carries over. 3 times 6 is 18. With the 2 that carries over, I get 20. And now I add it. 4. 6 plus 4 is 10. 1 carries over. 1 plus 3 plus 4 is 5. 1 and then 2. Now I had 2 decimals here and 1 decimal here. So my answer has to have 1, 2, 3 decimals total. Same number as decimals as the problem, and then I think about my sign. Positive times negative is negative, so my answer in the end is negative. There's more practice here, so let's get to done. And if you haven't been trying it, this is your chance, all right? Make sure you try it yourself before I do it to make sure that you know how to do it. Let's do this. Negative 2.01 times 3.3. So 3 times 1 is 3. 3 times 0 is 0. 3 times 2 is 6. Working under the 3 now, have to put a 0. And it's going to be the same thing because it's another times 3. And then add it up. 3, 3, 6, 6. Now, because there's 2 decimals here and 1 decimal here, my answer has to have 3 decimals. Negative times negative is positive. I am done. Now, we do remember, by the way, that if you are thinking about the answer, you can also think about the size of it to see if it makes sense. 2 times 5, if I forget the decimal and just look at the first 2 numbers, 2 times 5 should be something close to 10. So it makes sense that it's like 11, not 114, not 1.14, right? Likewise, 3 times 6 is closer to 18. So this is not going to be 215 or 2.1. So it's going to be closer to 2 digits before the decimal. Likewise here, it's going to be close to 6. And so that's why I think of it when I look at my final answer to make sure that the number of decimals I included. But it's fairly easy. Just count the number of decimals on each problem, and you're going to be all right. So here's another example, and I already know it's going to be positive because I'm multiplying 2 sets of decimals that are positive. 1 times 2 is 2. 1 times 3 is 3. Now working under the 6, put a 0. 6 times 2 is 2. 12. 1 carries over. 6 times 3 is 18. With the 1 that carried over, 19. So 2, 5, 9, and 2 when you add it vertically. 1 decimal here, 1 decimal here. The answer is 19.52. So that's how you multiply decimals. Not going to go over dividing decimals because there's nothing like that in the PFA. You're going to need it to know how to do that skill, but you're not going to need to do that in the power focus area, so I'm going to skip that skill. But we still have to do fractions. Now, the rules that I have written here are for the second method to find the common denominator, and you can totally follow those rules. And since I have several practice problems to try, I'm going to do it like that at least a couple times, and then I will do it the other way that I like to do it for the other times. All right, so I like to do it this way, though, because it does help save time not having to simplify at the end. So the first thing you need to do is list the common multiples of each number until you find something that they have in common, because you cannot add fractions that have different denominators. So 4 and 5 have to be listed. The next one here will be 8. The next one here will be 10. The next one here will be 12. The next one here will be 15. The next one here would be 16 because I'm adding 4. Next one here would be 20. And next one here would be 20. Oh, we found the common denominator. Now you count the number of steps that it took to get there. 1, 2, 3, 4, 5, including the first number. This was 5 steps. And this one was 4 steps. So the next step is multiplying each of these fractions by the number of steps that it took to get to the common multiple. The 4 took 4 steps, so I multiplied the top and the bottom times 5. And then I add that, keep the same signs as the original problem, right? Copy exactly like it was over there. And then it took 4 steps, so this fraction has to be multiplied times 4 on the top and the bottom. Okay. And so what do we do here? 7 times 5 is going to be 35. And then 4 times 5 is going to be 20. And then that's, by the way, how you multiply fractions, which is going to save us time in the bottom when we talk about that. You just do top times top and bottom times bottom. Then you do plus, negative. 1 times 4 is 4. And 5 times 4 is 20. And now I think about my final answer. I just write 20 in the denominator, right? So just write 20 in the denominator. And then I operate the top like the bottom is not there. 35 plus minus 4. These are different signs, so I have to find a difference. And the difference between them is 31. And keep the sign the biggest, which is 35. So the answer is positive 31 over 30. So that's kind of how you do it. It's a pretty straightforward method of doing that. I'm going to do it again using the same kind of skill on this one. But when I get to this one, I'm going to actually, I'll show you there's a different way to think about doing it. So I'm going to do this one using the same skill, but and then I'm going to go back to this one and use a different version of finding the common denominator, right? So again, listing the common denominators, start with 7. And then for the other one is 2. So then I go to 4 and 6. I don't necessarily alternate. I just go like until I pass the other number, and then I alternate. 2, 4. Otherwise, you can go too far in one before you realize that you already reached the common denominator. So if you do this, you will get 8. Now it's bigger than that, so I'm going to switch this one. This is 14. Now this is bigger than that, so switch back to here. 10, 12, 14. All right. So I finally got there. Notice it took 2 steps to get there, and then here it took 7 steps. So when you try to create your new fractions, you're going to copy the problem as originally stated. So here we go. 3 7s times. Now the 7 took 2 steps, so I have to multiply the top and the bottom times 2. And then this is minus half. Multiply the top and the bottom by 7, since it took 7 steps for the 2 to get to the common denominator, which was 14, right? I forgot to circle that to show you guys that it's the common denominator. All right. And now let's come up with our new problem here and figure out the final answer. 3 times 2 is 6. And 2 times 7 is 14. Minus 1 times 7 is 7. 2 times 7 is 14. So now we have both fractions with the same term, so we can actually put them together. You put the denominator there, and then do the top as if the bottom is not there. Now, here's where you have to use your rules of subtraction, right? So slash this one, change the sign, the number that comes after. 6 plus 7 is what we need to do because they have the same sign. Put them together. You get 13 over 14 as your final answer when you put these two fractions together. So yeah, it's a lot of work to do common denominator. But there is a shortcut that a lot of people prefer doing. And I'm going to show you this other version for the next 3 problems that we have to practice here. So the first one is going to be 5 and 8 and 4. But instead of listing the common denominator, this time I'm using a different trick, which is basically you rewrite the fraction, right? So I'm going to put that there. I'll leave a little bit of room there to show you what I'm going to multiply the top and the bottom by. And I'm copying exactly the same signs as the original problem had. Okay, now what you do here is that you see how this fraction has a 4 in the denominator? So what you're going to multiply the top and the bottom for is 4, because that is what is the bottom of the other fraction is. So you picked up at the bottom of the other fraction and you multiply both the top and the bottom. So instead of having to figure out the number of steps, you just use the other number as what you multiply the top and the bottom by. Okay, so that works. And actually, I prefer doing it this way. So then the next one is 8 sometimes. The problem of doing this way is that you have to simplify at the end sometimes. Now, because this other one is 8, I multiply the top and the bottom times 8, right? Because this one is 8 over here. All right, now I write the new problem. So 5 times 4 is 20. 20, and then 8 times 4 is 32. Okay, so then 20 and over 32 is the first one I have. Copy down exactly like the same signs. -1 times 8 is negative 8. And then 4 times 8 is 32. And now I just do the problem, copy down the denominator, and then do the top. Since the denominator is not there, I'm trying to do 20 minus 8. Because they have different signs, I have to find a difference, which is 12. And it's going to be positive since 20 is bigger than 8 and 20 is positive. Now, here's the kicker. Because you use this method, your answer is not simplified. It's not the least common denominator. And that's going to be very common when you use this method. And so if you need to simplify, which is not always required in a problem, you have to do that still. And I noticed that I can divide the top and the bottom by 2 here. So I'm going to take a step here of dividing by 2, both the top and the bottom. And if I do that, I get 6 divided by 16. But then I notice, oh, wait, I can still divide this by 2 on the top and the bottom. So if I divide by 2 on the top and the bottom, that's the same thing as 3/8. And that might be the answer that's in your actual multiple choice in the test. So you might need to have to simplify to find the answer if you use the other method. And that's the downside of using that method, is that you have to do the extra step of simplifying at the end. So you either do the work early on to try to find a common denominator, or you do the work later on to have to simplify. It just depends on what it makes most sense to you. We've got a couple more to practice with here. And again, if you already got how to do this, you can skip this and go to the next thing, which is going to be multiplying and dividing fractions. But I'm going to use the same method I just used right now to try to find this one. I'm going to do the problem in red just to differentiate from the problems that I did above. So I rewrite the fractions with the same signs as I did before. So 1/3 minus 2/5. But I have to multiply the top and the bottom by what's on the other fraction. So this one is 5 in the bottom here. So I'm going to multiply the top and the bottom by 5 on this one. And then this one down here is 3. So I'm going to multiply the top and the bottom by 3 on this one. And then I rewrite a new problem based on that. So -1 times 5 is -5. And 3 times 5 is 15. I copy down exactly the same signs. 2 times 3 is 6. And 5 times 3 is 15. And now I operate. So slash to change the sign of the operation. That's how you do subtraction. Slash to change the sign of the next number. Then copy down the denominators. It's going to be 15. And then the answer would be -5 plus 6. They have different signs, so I have to find a difference, which is 1. Keep the sign the biggest, which is 6. So my answer is 1/15. And this time I did not have to simplify. So you don't have to simplify usually when the common denominator that you find with this method happens to be the least common multiple that you would have found if you had used the other method. The reason we have to simplify it on this one is because the common multiple that we found is not the least common multiple. The least common multiple between 4 and 8 is 8. And so using 32 causes you to have to simplify at the end. But it is, for some people, easier to think of it doing it this way. Running out of battery here. So let's get this plugged in. I don't even know why it's not plugged in the first place. My apologies. We got one more chance to practice, and I hope that you take advantage of this to make sure you practice a little bit more. I'm going to erase the other problems that I've done just to not confuse anyone. I'm going to leave this one right here because I'm going to use the same method. So I'm going to use that one as a reference. So I'm doing this one right now. So I'm doing 3/4, copied it down, leave a little bit more room this time than I did last time to actually be able to write my multiplication step. All right. Okay, so let's do that. So notice that the bottom here is a 7. And so I'm going to multiply the bottom and the top by 7, which is my other fraction. And then the bottom here is 4. So I'm going to multiply the top and the bottom times 4. And when you get to copy down the new problem, make sure that you keep the signs of the original problem exactly like they were. So 21 is the top. 4 times 7 in the bottom makes 28. minus, just like the original problem, 4 times 1 is 4, and 7 times 4, again, 28. Now, this does happen to be the least common multiple between these numbers, so I might not have to simplify as much. Next step is to take care of the subtraction. So change the sign of the operation, change the sign of the number that comes afterwards, copy down the denominator, and do the top like the denominator is not there. So 21 and 4, they're both the same sign, so you just put them together, and you get 25 divided by 28 as your final answer. And so that is how you add and subtract fractions. Then we just have to do dividing and multiplying fractions. So let's do that too. So as you can see here in the examples, and this time, just to save time, I actually left the examples already done, especially since we've already talked about that. To multiply, all you do is top times top and bottom times bottom, and then think about the sign, right? And simplify if you need to. So in this one, 3 times 2 is 6, 5 times 3 is 15. Because there's only one negative sign, the answer has to be negative, and you can simplify it by dividing both by 3, and that actually should be 2/5. So let me fix that. Same thing as 2/5 when you divide both top and the bottom by 3. When you divide, it's similar, except you have to copy that flip. So what you do is you copy the first fraction, change the sign to multiplication, and then flip the second fraction upside down, and then follow the same process. 3 times 3 is 9. 5 times 2 is 10. Negative times negative is positive. Boom. Let's try these with these problems right here. All right, so the first one we have to try. Let me get a little closer, actually, so that we can actually see the problem a little bit better. So the first one is 3 times 1, which is just 3. 8 times 4, which is 32. And then you think about the sign. Negative times negative is positive, so that's my final answer. All right, let's try this division one here. So that you just copy the first one, change the sign to multiplication, flip the second one, don't mess with the sign, just flip the fraction upside down, then you multiply. 1 times 5 is negative 5, 3 times 2 is 6, negative times positive is negative, and so the answer is going to be negative. And that is your final answer. If you haven't tried it yourself by now, make sure you pause before I try these for you. So 2 times 5 is just 10, and 3 times 8 is 24. Now, negative times negative is positive, so your answer is positive. It is possible to simplify this. So just in case the multiple choice is not there, it might be because you need to simplify. And you can, if you divide the top and the bottom by 2, this will come out to 5/12. Let's try to do this one now. You copy the first one, 3/7, change the sign to multiplication, flip the second one upside down, 2/1, and then do the multiplication. 3 times 2 is 6, 7 times 1 is 7, negative times positive is negative, so your final answer is negative 6/7. And there you have it. That is the skills of 7th grade, worrying about the signs, but reviewing the ideas of how to multiply and divide fractions, and also add and subtract. The last thing I'm going to talk about that might be useful for you to actually pass this exam is the idea of order of operations. Remember that when you're doing order of operations, you must first do parentheses, then you do exponents. You can see a lot of those in 7th grade. Then you're going to do multiplication or division. They are not with the multiplication first. They are tied. Then you do addition or subtraction. Okay. Now, remember that if you have multiplication and division on the same step, you do the one in the left first. Okay? Whichever one is on the left goes first. The same thing is true if you have both subtracting and adding on the same step, you go left first. Now, if you just do one step at a time and copy down the rest, you can make sure that you make less mistakes. So let's see these in action right here. You can try yourself before I do it, right? So the first thing you need to do here is division. Why not the multiplication? Because they are tied. So I have to do whatever comes first. So I'm going to do this step here first and copy down everything. Only do one step at a time. 3 divided by 3 is 1. copy down everything else. The next step I have to do is this 3 times 2 here. So I copy down everything else, and then I do that step, which is 6. Now, you might be tempted to add first now, but remember, subtraction and adding are actually tied. So I'm actually going to do this subtraction here first. Slash, slash, I am putting together numbers of different signs, so I have to find a difference, which is 3, keep the sign the biggest, 4, and then copy down the rest. 3 plus 6 gives you 9. And there you have it. Follow the orders of operation to make sure you do it right. Let's do these practice problems. You try yourself before I do so. So 4 minus 2 plus 3, right? So I have to do the subtraction first because subtraction and adding are tied. So this is 2 plus 3. I only do one step at a time. 2 plus 3 is 5. Over here, I have to do in order of operations, I have to go from left to right. And so I do this multiplication first and then copy down the rest. 6 divided by 2 times 4. Notice how I only take one step at a time. You might be tempted to multiply first because m comes first in PEMDAS, but remember multiplication and division are tied. So you're actually supposed to do this next, and you get 3 times 4, which is 12. All right, and then on this last one, the toughest one of the bunch, I have to do parentheses first. Within the parentheses, multiplication needs to come first. So I copy down everything else and resolve that, which is 4, 2 times 2. Now I still have the parentheses to worry about, so I'm going to do this step right here inside the parentheses and copy down the rest, and that's going to be 7. And then I have a subtraction problem to deal with here. Slash this, change the sign of the operation. I am adding numbers that have different signs, so I find a difference, which is 4. Keep the sign the biggest, which is the 7. -4 is your final answer. Finally, can you try to solve this one? It's a quiz problem with a lot of different steps. Believe in yourself, do one step at a time, follow the order. Start with parentheses. Within the parentheses, we have multiplication here first. And even though you might be tempted to do something else, don't. Copy everything else carefully, exactly as listed. 3 times 2 is 6. And the next step, I still have a parenthesis to worry about. So I am going to worry about this right here for my next step. Copy down everything else, resist the temptation to do anything else one step at a time. Okay, so now I have to do this one right here is division is the next thing that I need to do. So I have to do the 3 divided by the 9. All right, so then copy down everything else. 2 minus 4 plus 3 divided by 9, which is 1/3. All right, and then this is times 2. All right. Next step has to be this multiplication right here. So copy down everything else. 2 minus 4 plus 2/3. Right? Because this is if that was a 1 down here, and it's 2 times 1 is 2, 3 times 1 is 3, so that's what you get. Next, I have to do the subtraction up here, this one right there, and slash and slash. I'm adding things that have different signs, so I'm going to find a difference, which is 2, keep the sign the biggest, which is the 4, so -2 plus 2/3. All right, so then you can turn this into a common denominator if you need to. It shouldn't be that bad to do that. If you think about it, if you have 2, by the way, these are different signs, so you have to do is find a difference. So what is really the difference between 2 and 2/3? So sometimes when I'm doing fractions, I like to think about it instead of actually doing the common denominator thing, especially when I'm doing mixed numbers, because it actually makes sense. So 2/3, if I take away 2/3, it's going to be 4/3. So your answer should be 4/3 here. And since the negative, the 2 is bigger than the 2/3, the answer is going to be -4/3. But you could have done that also with common denominator, because another way of writing 2 is 6 divided by 3, right? Negative. And that plus 2/3 equals, keep the third at the bottom, and -6 plus 2 is just -4. All right, because there are different signs, so you keep the sign the biggest and find a difference. And so that you go, order of operations with a challenge at the end, and that's how you do it. And that was the workshop. It took a while to get through it because it is a lot. All right, it is a lot of skills that are involved in this power focus area. But I hope you found this helpful, and you practice with me. And good luck, and don't do anything that would make a member proud.